Alright, so this calorimetry problem is a little bit different than the last one, which was a salt solution dissolving into water. In this case, we have two aqueous solutions, okay, potassium hydroxide and hydrochloric acid, and they're being mixed, and we're going to have a temperature change, and we need to find the delta H of neutralization for this reaction. So first thing we have to do is write a balanced equation. So we have aqueous potassium hydroxide, and we are mixing that with aqueous hydrochloric acid. This is a simple neutralization reaction, so we're going to make water and a salt. Water, designate that liquid, and in this case we'll make KCl, which from our solubility rules with an alkali metal, KCl, it's going to be aqueous. Okay, so that's part one. We have our reaction written. Second part now, we need to do our calorimetry. Again, same thing as we do in the other ones. Our Q of reaction is equal to the negative Q of the calorimeter, and remember, Q of reaction is simply the delta H times the moles, and the Q of the calorimeter is going to be, well, negative in front, and then ms delta T for our coffee cup calorimeter. Okay, so once again, we solve this for delta H. It's going to be negative ms delta T over the moles over N. Now we just need to plug in the various parts. Okay, so if we think about how we're going to measure these different things. The mass, we're going to have to do this a little bit differently than when we had the salt and the water. We can't just add it. What we need to do is we need to add these two volumes, right? So at the end of all of this, we're going to have 203 milliliters. Okay, you can see that, how we got there. We simply added 105 and 98. Now we're going to rely on the fact that assuming it's the same density as water, unless we're given another one, there is 1 gram per 1 mil of water, okay, and therefore we're going to end up with 203 grams. So that's our mass. Okay, specific heat, we're going to assume the same because we're not given anything different, so 4.18 joules per gram degree Celsius. The temperature, delta T, simply going to be the final minus the initial, so it'll be 31.3 degrees Celsius minus 24.6 degrees Celsius, and so what we're going to get for the delta T will simply be 6.7 degrees C. And now the last thing we need to figure out from here is the moles N. So the trick here is that we have moles of two things in this reaction. So what we really need is the N of the limiting. So we're going to test both of these. The first thing we're going to look at is going to be the potassium hydroxide. So we have 0.105 liters, and that's going to be times 0.95 molar KOH, and what we're going to get out of there is 0.0998 moles of KOH. And for the HCl, we have 0.098 liters, and we're going to multiply that, molarity times volume, remember, in liters is going to give you moles, times the 1.40 molar, and from that we get 0.137 moles of HCl. So the limiting reactant is going to be the KOH, and that therefore is going to be the one that we use. We can't use the moles of the HCl because we're not reacting all of them. We're only reacting as much as we can to use up the 0.0998 moles of KOH. Now note, because this is a 1-to-1 ratio, we don't have to compare it to water to figure out, right? This says per mole of H2O formed because it's a 1-to-1 ratio. 0.0998 moles of KOH will make 0.0998 moles of water. You do have to be careful when these get to be 1 to 2 or 2 to 3 or something like that, that you actually do the conversions and be careful for that. Alright, so now I'm going to just plug these in and we're going to solve for our delta H. So delta H is going to be equal to negative 203 grams, 4.18 joules per gram degree Celsius, and our delta T, note it's positive this time, 6.7 degrees Celsius. We're going to divide that by the moles of the limiting reactant, so 0.0998 moles. And what we're going to get out of this is going to be negative 56.966. Remember, this is joules per mole, okay, and this is per mole of water, because as I said, 1 to 1, 0.0998 moles of KOH makes 0.0998 moles of water. And we need to convert that into, now, negative 57 kilojoules per mole. So I divided by 1,000 and then rounded it to two significant figures because of the temperature. 6.7 goes to 2. Alright, so there you go. The delta H of this neutralization reaction is negative 57 kilojoules per mole.